Tangent line question 1. Find all the points a f of a on the graph of y equals log of x minus 1 plus 5 such that a tangent line at a f of a passes through the point 1, 4. First of all, we need to graph this function log of x minus 1 plus 5. Well, that's just log x, which looks like this, shifted to the right by 1 unit, so the asymptote, the vertical azimuth, shifts over 1 unit, and shifted up 5 units. Anyhow, it looks like this. Now, the strategy is to find the slope of the line joining 1, 4 and this point here, which is a log of a minus 1 plus 5. Call the slope m, then evaluate the derivative dy dx at x equals a, set m equals dy dx, and solve for a, because you have one equation, one unknown. And then we'll find the x-coordinate of the point of tangency. We can think of this question geometrically. If you take a ruler and rotate it in such a way that it goes through 1, 4 and it just touches the curve. So if we do that, we'll see that we get this point right here. And but we're going to use calculus to solve this question. Okay, let's start. Solution. Let's find the slope of the tangent line joining these 2 points using the slope formula. Okay, so that's going to be m is equal to y2 minus y1 divided by x2 minus x1. So m will be log of a minus 1 plus 5 minus 4 all over a minus 1. Okay, now let's take the derivative of the function, which is y equals log of x minus 1 plus 5 dy dx is equal to, derivative of log x is 1 over x. So d dx of log x is 1 over x. Derivative of log of g of x is 1 over the inside, 1 over g of x, times the derivative of the inside, that's using the chain rule, that's g prime of x. Okay, so that's going to be 1 over the inside, 1 over x minus 1, and derivative of x minus 1, derivative of x is 1, derivative of negative 1 is 0. Plus derivative of 5, that's just a constant, its derivative is 0. Now evaluate this derivative at the point of tangency at x equals a, which is at this point here. Okay, so we get dy dx is equal to 1 over a minus 1. Now the key point when you're doing this question, or this type of question, is to find the slope in 2 different ways. 1, using the slope formula, and 2, using the derivative, and equating those 2 quantities. So now we have 2 expressions for the slope. This one and this one. Let's call this star, and this one double star. Okay, so the slope is log of a minus 1 plus 1 divided by a minus 1 is equal to 1 over a minus 1. I can cross out, cancel out the a minus 1s, and we'll get log of a minus 1 plus 1 is equal to 1. Subtract 1, bring it over to the other side, you get log of a minus 1 is equal to 0. And now exponentiate both sides, e to the log of a minus 1 is equal to 0, and we get a minus 1 is 1, so you get a equals 2. This is the x-coordinate of point of tangency. On the graph, it's right here, x equals 2, and that's the point that we have here. All right, so now let's find the y value. F of x is log of x minus 1 plus 5. Let's substitute a equals 2 for x. you get f of 2 is log of 2 minus 1 is log of 1 plus 5. Log of 1 is 0. 0 plus 5, that's 5. So the coordinates of the point that we're looking for is 2 and 5. Such that a tangent line goes through 1, 4 and is tangent to the curve. And that's the point here. Let's label this as 2 and 5. All right, thanks.